All right, balancing chemical equations using polyatomic ions. So, same thing as before, we list the elements that were given. On the reactant side, we have Na. We also have O and H, two different H's. We do not have an OH over here, so we're going to have to list them separately, an O and an H. That H covers both this H3 plus this H. We also have PO4, which is phosphate. We have the PO4 on the product side. For the purposes of balancing chemical equations, you can use the phosphate as its own individual, pretending it's an individual element. It is not its own element, it is a polyatomic ion. Polyatomic ions, this has a negative charge and it bonds with something that would have a positive charge. Uh, so we would have our NAs. So NAs over on the reactant side, there's going to be one. On the product side, there's going to be three. O's, we have only one. Remember, we're using the PO4 as its own individual for purposes of balancing, as if it was an element. So a lot of times it's hard to remember, especially when you're first starting out. It's hard to remember that there's only one element here. So if it helps you, put down the ones. Um, it just helps balance chemical equations. So oxygens, we have one oxygen over here and we have one oxygen over here on the product side. We have hydrogen. We have one hydrogen plus three more, which is going to give us four hydrogen on the reactant side and two hydrogen on the product side. We have PO4s. We have one PO4 over on the reactant side and one PO4 on the product side. So what we're going to then do is look. We have PO4s are balanced and our oxygens are balanced. Our sodiums and our hydrogens are not. Go for the most complex compound. Leave the most simple compound for last. Sometimes it can be diatomic molecules, chlorine, oxygen, hydrogen, and the like. Sometimes it's water, sometimes it's OH. So, and sometimes it's just an individual aluminum or something like that. So, we want to basically try to balance this. We have three sodiums on the product side, and we need three sodiums here. So we can't change any subscript, but we can change coefficients. Coefficients go in front, and the 3 is multiplied over all of these elements, not just the first one. So 3 times 1 is 3. 3 times 1 oxygen is 3. 3 times 1 hydrogen is 3, but we have 3 more over here, so that gives us 6 hydrogen. And then we're going to leave the PO4s for the moment. So we have our sodiums are balanced and our phosphates are balanced, but we need more hydrogen and oxygen on the product side. What number would we put in as a coefficient in front of the H2O? Basically, we have 2 hydrogen now. What number times 2 will give us 6? That gives us 3. So we're going to cancel that out. That gives us 6. 3 times 2 is 6 for hydrogens. 3 times 1 is 3. And voila, it's balanced. So